Alright, so the plan for today is to look at the simple use of the storm and sanitary analysis, the SSA package. I don't claim to be any type of legendary hydrological engineer. In fact, I probably only know just enough to get myself into deep trouble. So I know enough to be able to show you the entry, if you like, into SSA. Those of you who are hydrological engineers will have a lot better idea of how you use all the components and the more complex components of SSA to do a proper network analysis. But hopefully I'll be able to show you something here today to get you started. There are a bunch of videos on YouTube that Autodesk has put there that you can go and have a look at and get some extra information about SSA. And I believe there are some on the Autodesk website as well, but I'm not 100% on those. They might have put them all on YouTube, or there may be duplicates on YouTube. All right, so that's the plan. First of all, licensing. To be able to use SSA, you need to have a version of AutoCAD Civil 3D 2011 on your machine. It looks for a valid license of Civil 3D 2011, and then it starts itself up. It must be 2011, 2010, it won't do. So load yourself up a copy of one of those, even if you're not using it, and then you'll be able to start up the SSA. What we're going to look at is, first of all, we're going to open up a drawing in Civil 3D, extract the data from that drawing, and bring it into SSA. Then we're going to have a look at some of the analysis types in SSA. There's a bunch of stuff it can do. And then we're going to go and have a look at adding the data required to do an analysis, a stormwater analysis, and things like IDF curves and in relation to the simple pipe structure that we'll have from Civil 3D. Run a simple analysis, have a look at some of the output, and then transfer it back into Civil 3D again at the end. All right, so that's the basic plan. I don't think there's anything else we need to cover there, so let's jump into a demo. So let me just transfer to Civil 3D here. There we go. Hopefully your screens are catching up reasonably quick. And I'm just going to open a drawing here. Just a simple pipe network drawing, which is that one. In fact, I think that's actually the wrong one. Let me close that. And get the right one. Desktop. This is a repeat of a session that was given at the recent Solutions Day in Sydney. I'm not going to be doing anything extra in this session as on top of what was done at that session in Sydney. So if you were there, you probably don't need to spend the next hour looking at your screen. If you weren't there, though, it's a good chance to catch up with everybody else. All right. I have here a simple network. If we zoom in, we've got a couple of pits there, a couple of what do you call them? Drains on the side of the road, entrance pits. We've got a line running down the centre line, well, not the centre line, but the centre of travel of one of the lanes of the road there. And the pits are connecting into those manholes, and then those manholes discharge down the hill into down here. We've got a wing wall structure on the end of our network. It's those things we looked at last week in the previous webinar. Okay, have a look at the profile of those, and this is what we're looking at. We've got 375 pipes running underneath the street, and we've got 225 reinforced concrete pipes running from the pits into the manholes. Okay, so that's all pretty straightforward, and that was covered last week. Alright, so what do we want to do? Hopefully your screens are catching up reasonably to mine, not too bad. Alright, what we want to do is go and have a look at one of these pits, and I'm going to select my surface here. You can see the triangulation in the background there of the surface. We've got a roadway down the bottom of the screen. I'm just going to pick that surface, and from up here in the ribbon we have an option to, well, most of you will have seen that water drop tool that's used. It puts a little polyline on your surface, like where a water drop would run if it ran on your surface. There's another one here that's been for the last couple of years. It's been in Civil 3D as catchment area, and we're going to use that to determine the area that is flowing into these manholes. Sorry, not manholes, pits or sumps. So let's go catchment area and go OK. And then I'm just going to click on where this the sump is, and you'll see it's put in a polyline that traces out all the area of the surface that is flowing to that point, if you like, or above that point, an elevation above that point. Just let the screens catch up. You should be able to see that there now. I'll do the same thing on the other pit, which is there. Okay. Having done that, I'll just escape out of the command. Now if I highlight those, you can see that the second one I selected has actually got a duplicate boundary with the first one. Escape out of that and highlight the first one. That's not too much of a problem, because what we need to do is we're going to export this pipe network and actually parcels from this drawing as a land XML and take that into SSA. So that common boundary is actually going to get stripped out when we make our parcels. So let's go and do that. We need to make it parcels because that's what a land XML understands and can transfer between drawings or between applications. So what I'm going to do is go on the Home tab with ribbon here, go and click on Parcel, create parcel from objects, select the first one and the second one, hit enter. It's going to put it in that site, that's fine. It's going to have that style and erase those polylines, so that's what we want. Okay, so now we've got two little parcels. We have a look at the areas of those. It's 5,251 square meters, and also about 5,000 square meters on the other one there, which just proves that it has actually split those two into two distinct little areas. If you click on one, you can see it's actually highlighting that boundary of only one of those areas. So that's what we wanted. Alright, from here we go and make our land XML export. So let's go and do that. We go to Output tab of the ribbon, Export to land XML, and what we want out of here is just the pipe network and the parcels, but it doesn't really matter. We can leave everything turned on, and SSA will only use what it needs out of the XML. So we go OK to that. And let's put it on my desktop and we call it SSA. I think I've already got an SSA 1 there, so we can call it SSA 2. Okay, that being done, we can go and start up SSA. So for those who want to know what it looks like, here we go. I'll just I'll just go to my desktop, start it up. Here she comes. Okay, it's taking a minute. Here she comes. All right. I think it's just getting confused with my PowerPoint here, so let's go and find it. This symbol with an S. There we go. Okay, that's better. Doesn't usually take that long to come up. Just got itself confused, obviously. All right. So this is basically the interface. What is the interface, in fact? It's not much more than that. All right, what we want to do is go File, Import a land XML file. You can see there's a bunch of stuff it can import. EPA swim files. GIS import is interesting. It can read and output shape files, which is quite nice. Land XML, which is what we're going to be using. You can bring in background images and a drawing as a background too if you want. It can read, I think this is a new part that was introduced, hydroflow storm sewers files, XP swim files, and that's about it, what it does on the import. What you see, what we've actually got here, this SSA that Autodesk has put out, has had a couple of extra things added into it. I think the hydroflow storm sewers operability is new. I haven't confirmed that, but I think so. But basically, this is what you would have bought last year from Boss International software writers for lots of money. So it's what we used to be called the StormNet application, and it's the unlimited nodes version of that, which I believe cost about $12,000 at the time. So that's a pretty good extension to have, to be able to have this directly on Civil 3D. All right, so we're going to load up a land XML file. Let's go to my desktop, I think is where I put it, SSA2. And this is what it brings in. The green hatched areas are our parcels. You can see that it's, each is subdivided into the correct area. And we've got junction structures between the pipes, and we've got our pipes. Now if we go and double click on any of these, we've got our pipes there. You can see it from the top. It's from the description, it's a 225 nominal bore reinforced concrete rubber ring jointed pipe, which is the description that came from Civil 3D. The diameter here, though it's in centimeters, is the diameter that came from our parts catalog in Civil 3D. And we've got the lengths and elevations and all of that as it comes from Civil 3D. Now, what I should point out, we've also got, while all the pipes in Civil 3D are circular, in SSA you've got the ability to use open channel pipes of different sorts, different shapes, triangular ones, parabolic, rectangular, all sorts of different things. Same with the pipes. We've got, rectangular and triangular pipes. We've got with basket handle, egg-shaped, I guess we call that. But the one we're just going to be dealing with here is circular, just to keep it normal. And it's, oops, my diameter, having changed all those things, my diameter's changed. Let's just put that back at 22.2 centimeters, as it should be. Okay, we can close that. What I do want to do is, and it's quite useful to remember to do this, is if you have up look in the top part of the interface here, there's a little padlock. You want to lock that so you don't accidentally move your nodes and pipes around the place, because we've set those in Civil 3D. We don't really want to be moving them geographically, so lock that up before you go too far. All right. So that's our pipes, and our structures are the same. We can double click on those. Brings up the structure information. We've got this table at the bottom here which actually has all the structures. So if I click on one of these other lines in the table, you can see flashing in the background the actual one that we're working with. Similarly, if we have that in place, we can click on one of these things and click the show button, and it'll take you right to the one that we're talking about and make it flash in front of you, so you can make sure you're on the right ones. All right, so we don't really need to deal too much with those, so that's fine. I just wanted to show you that. close that. Okay, what we need to do now is take our sub-basins, parcels that came in, right-click on one of those, on the little glyph in the middle, which is actually what you click on to get the properties of that area. And we go connect to, and we connect to there, so all that area is going to flow into that sump, and we do the same thing with the other one. Right click, connect to, and make it flow into there. Okay, so that's told it where the water's coming from. We need to go and, well, before we get too far, we actually need to look at the input project options and define what sort of hydrology method we want to use. What you want to do is set right at the top here first. I'll just let your screens catch up. There you go. Right at the top here, you want to set metric units. I think by default, if I remember correctly, it starts off with imperial. You set it as metric units there once, and it will remember that, so that's fine. Flow units, cubic meters per second. I have seen a note from Autodesk saying that, or note a support case that had problems with liters per second, so I would suggest leaving it as cubic meters per second for now until they fix that one. Hydrology method, there's a bunch of them. Rational is the one that most people would be familiar with, I guess, perhaps the modified rational. We've got EPA swim, we've got a whole bunch of American ones. There's the SCS TR55 and the TR20s, HEC 1. So you've got a bunch you can check, you can choose from there. I'm just going to go for rational for this one. As I say, lots of those will get me into trouble. And time of concentration method, Kirpich I think is fairly basic. I might go for SCS TR55 for working out the time of concentrations. And something a bit more complex. We'll see that as we go. You've also got down the bottom here, the hydraulic routing type or specification. We've got hydrodynamic, which is a full hydrodynamic analysis, which does, well, if you go and have a look in the help, it does all sorts of stuff. Steady flow, which is the basic, and the kinematic wave is somewhere halfway in between. Not quite so computationally intensive, but still takes account of a number of different factors. So we'll go with kinematic wave, and main force equation, we've got a couple of options there. I'll leave it on Hazen with Williams. Okay, well, let's close that. That's all we need to do in there. And let's go and have a look at the IDF curves, which are over here in the little toolbar at the side. Effectively, we've set it to a rational method, so we need to go and set some IDF curves to use. Let's double click on that. Right, I've got the last ones I used to load it up there. By default, it'll have these default ones in there, which are actually conversions, I think, of the imperial ones that they have from the States. So that's not going to be terribly useful to us. So what we want to do is be able to overwrite our own IDF curves in here. That's quite simple to do because you just do it with this table down the bottom here, and you can cut and paste from Excel or anything with a cell-based format. So you can see the rainfall equation here is set by IDF table. We can set it by using the coefficients as well if we want. If we click on one of those, it just has the the ability to set those by coefficient, but we'll just use the IDF table and return period of however many years we want. Okay, so let's go and load that up. I'm just going to make sure I've got this right. Oh, it's for 2. Okay, we'll see how we go. All right, I'm just going to go back and we'll duplicate that for you to show you how it's done. Okay, so this is the basic IDF curves to start off with. Not particularly useful because they'll be American based. So I've gone over to Niwa in New Zealand, which has our which is the we can download from the website, from the NEWA website, the IDF curves for areas in New Zealand. I think this is Auckland, if I recall the correct one I grabbed, and I just grabbed it as a an Excel table. So we've got our return periods here and our storm durations at the top. So I'm just going to select a bunch of cells here and right click copy, go back to SSA, and if I just cut them up in the grey here area, right click and paste them in, and then click somewhere in here, you can see the curves straight away update. So all that information has come through from the Excel or anywhere else you happen to have it in a tabular format in cells, and that'll come through. Now, if the tables you have don't necessarily match these storm durations or the return periods, you can just right click in here and go insert a return period. So I might, or a storm duration in fact. It's just the same thing. I might want a return period of say 7 years. Okay, and it puts an extra line in the table, and obviously when we cut and paste into that table we'll just fill in those cells. If there's some you don't want in here, you can right click and go delete the return period. Delete return period 7, yes, and that's gone. Okay, so it's pretty easy to modify this table and then just cut and paste in with the information that you have. Talking with Autodesk Australia, their plan at the moment is to try and set up a web repository where people who have made their own IDF curves can, well, from this one here I can go save and save it into there under whatever name. So you can use it in the future obviously, but the suggestion is that Autodesk Australia was going to, or will, go and make a web location where you can upload curves that you've saved for a particular area and download any for other areas that other people have made. So save people reinventing the wheel, just have like a library, if you will, of IDF curves we can go and look up, which sounds like a pretty good idea to me. All right, so that's pretty straightforward. So we'll close that one, and we've got that set as our IDF curves for this particular project. All right. Next thing we want to look at is going and having a look at the time of concentration, etc., for all of these two catchments. So let's double click on one of these subbasins. Okay, so the area has come through from Civil 3D, from the parcel area. That's essentially all the information that Civil 3D has, so we need to put in the extra information that's required in here. There is a version of, or there was a version that you could buy of SSA that, well, sorry, of StormNet, when it was still StormNet, that ran within Civil 3D. This is the standalone version. That's what's been released at the moment. I understand that Autodesk have actually bought both versions, and also I've been told they also bought RiverNet and WaterNet, which are other applications for doing, I think, floodplain analysis and pressure pipes, which would be quite interesting when they come out. For the moment they've only released this one, and I understand they are planning to release the one that runs within Civil 3D as well, but probably not this year. So we'll see when that comes out. But for the moment, they've given us this to work with, which is the standalone version. Okay, you can see in the background there that little cursor blinking in the background. Well, hopefully you can on your screens. You should be able to. So that's highlighting again the sub-basin we're setting the area for. And we can switch to the other one down here by just clicking on in the table, or we can click on screen for the one we want to switch it back. It's the one we want. All right, we're going to fill in some of this information we need. So physical, you can change the area in here if you don't like that, if it's wrong or it's come through and you want to modify it, that's fine. What we've got here is the time of concentration for the TR55. Obviously, whatever method we set in the project options will have this screen changes, if you like, and you've got different options for different coefficients and things you can add in here. Okay, so let's just do some of this. Let's go for Manning's roughness for, we're talking about sheet flow here, grass cover, poor grass cover, moderately rough surface between 0.3 and 0.4, so let's make it 0.35. So put in there 0.35. Flow length, you can type in the flow length, or you can actually measure off screen if you like. There's a little measure button in here, you can scooch it around, hit enter when you're finished, and it'll actually put in that flow length for you. 151 meters, and a slope. Slope, we'll need to just switch back to Civil 3D for a moment. The easiest way to do that is get it directly from your surface. Just let your screens catch up there for a moment. It's still catching up for some of you. There we go. You should all have it now. Select your surface. Go and add a label. Add a slope label. Go 2 point, and between there and there, and another one between there and there. So I know that the hill slopes down that direction, so that should give us a pretty good idea. Zoom in a bit, and we've got 15% and 14.9%. So pretty straightforward. You can just get the slope for those areas. Hopefully you can see that on your screens is showing up as 15%. Switch back to SSA and slope of 15. 24-hour rainfall, let's put 30 mils in there. And click somewhere else. So we've got time of concentration of 51. Let's just make that. Oops, sorry. Let's make that about. Just want the numbers to work out here, so I'm just. Let's put in about 50. What do we get there? 78. Alright, that should be pretty close. Just wanted the numbers to work out correctly for what we're going to do further down the line. Obviously, I've made this up. You guys would have a more realistic situation to deal with. Then you go through and you'd set your shallow concentrated flow figures, you'd do your channel flow, etc., etc., and you get a report out at the end. The time of concentration method if you want to have that out as well. I'm only going to just do the first part, the sheet flow here. That's why I was adjusting those figures. And we'll go to the next parcel. And 0.35, flow length of 78, slope of 15%, 30. I think that should be the same as what we had more or less. Yeah, it's the same as the other one. Let's change that a bit and run that up to, let's make that. Okay, so times of concentration are slightly different for each one, so that's a little bit more realistic. Okay, so I've got those things sorted. We then need to go, that's time of concentrations, we need to do a runoff coefficient for this area, for this both of these parcels. So let's go and select runoff coefficient for that one. For pasture, should we say with less than 25 years? Let's go for, say, that one. Just double click on it and it'll bring it through. Usually you have different, not the entire area is all the same runoff coefficient, so we've just made that 50%, shall we say. Come down here, put another 50 in there. You can see the area is adjusted, and we'll have part of it as, say, forest, less than 25 years perhaps, something like that. And we've got a weighted coefficient of 0.28. We'll do the same for the other area, 0.44, 0.13, 0.44, 50, and 0.13. You can see when I got it wrong, it had made a red, well, I had an area greater than 100%, so it made a red flag for me to show that something was wrong. and that's our weighted coefficient for that one. Okay, same as that one. All right, so that's the basic information we need now. Obviously, there's lots of extra stuff you can do in there, but I'm just going to do a quick example for this session. We haven't got a lot of time, really. Okay, so that's those two areas done. All right. I think we should be just about ready to run the analysis. So that being done, what I might want to do though is just go and have a look at these pipes. Double click on one of those pipes. That's the 225s. Close that. And this one here is the, well, it's a 225 as well, is it? Okay, that's fine. Close. And that one there should be a 375. Yeah, there's our 375. Okay. Let's run the analysis. So what we need to do is go to analysis. First thing we need to do, there's two steps. The top one here is analysis options. Just let your screens catch up there a minute. Okay, top one is analysis options. We do that first, then we go to perform analysis. All we need to do is how long do we want to run this analysis for. Let's just go for 1 day down here. And we can set time steps and all sorts of stuff in here, but as I said, I can get myself into serious trouble if I start playing with those. You guys have a much better idea of what should be set in there. Storm selection, we can do a multiple storm analysis. We can do several of these at the same time, several different return periods. I'm just going to do the 100-year return period for this one. 100-year storm, and go OK. And let's go for, well, that being done, we can just go and perform the analysis. If we've done everything correctly, it'll run. If it won't run, if we haven't entered some of the data that it needs, it'll tell us so. Analysis successful, so I'm happy with that. And we can save the analysis. It's going to save it on the desktop, so as a SOL, a solution file. So let's just go OK to that. All right, we want to get some output. So we go to the next tab at the top, which is output. And pardon me, we can then go and get a profile plot out of this thing. Most people want the profiles to run from bottom to top, so I click at the bottom first and run up to here, and it traces through the network to give a profile for us. So we can go show plot, and it gives us a little plot there to begin with. You can see that it's got a whole bunch of information at the bottom there. Oh, there. Yeah, hopefully your screens have caught up. Yep, there we go. Now we're catching up. I'm just going to get rid of that table at the bottom by right-clicking. I've got a whole pile of options in here. I'm going to delete the summary table so you can just see a little bit better as we're doing this on your screens. Okay, so let's go and have a look at this analysis. So what we do is we've got our profile plot or our profile up. We go output, that's what we're talking about, and go output animation. What it's going to do is it's going to tune through the time steps for the analysis, and it's going to show us the water in these pipes as a blue line or blue solid, and the red line there is the hydraulic grade line, which will pop up and show us the maximum hydraulic grade line as the analysis runs. So let's just turn the animation speed up a bit here. I think full speed we'll probably need. Hopefully you guys will be able to see this on your screens okay. Go play. And you should see the water filling up slowly as we go through. We've got 12 minutes elapsed time at the moment as it goes through calculating, and it's pushing that that hydraulic grade line up. Okay. Let that go for a bit longer. It's calculating very slowly. It must be because of everything else I've got running on my machine at the moment, the GoToWebinar and everything else. Let's just pause that. load again. There we go, just going faster again now. Got itself stuck obviously. Alright, so you can see that the 225 pipe up the top is probably, well, it's almost full, so that's not too bad from the EG line, the hydraulic grade line I should say. The other one down the bottom there is probably a bit oversized, so we can change that. So let's just stop that analysis. We'll stop that graphic. Pardon me. And well, we've also got another option here. If we right click on here, we can show the energy grade line too in green, if we wanted to see that as well. Let's just turn that off for the moment. Okay, so this one down here is probably oversized. So if I double click on that pipe, it brings me up the information about that pipe again. And we can see down here that we've got a peak flow of 0.6 cubic meters per second. 0.06, I should say. It's pretty small. And a design flow capacity for that particular pipe of 0.43. So we can say, okay, well, that's obviously oversized. We can modify that on the fly if you like. So the way to change that, I can see that these other pipes, which are my 225s, have an internal diameter of 22.2 centimeters. So I'm just going to change the internal pipe diameter of this to match. Now I want it to match because when I take this back into Civil 3D, that diameter needs to match one of the pipe sizes that is in my pipe catalog. If it doesn't match, it just won't put the pipe in. So you do need to make sure that you've got the internal diameter of the pipe matching what's in the one of the pipes in the pipe catalog of Civil 3D. Obviously, if you've already got the pipe in here, it's easy to do. Otherwise, you need to just flick back to Civil 3D and make that look through the list and see what the internal pipe diameter is. Let me just show you how to do that quickly. We've got a bit of time. If I go into my Settings tab in Civil 3D, I'll just let the screens catch up. It's coming through slowly. Go to the Settings tab in Civil 3D to get into the styles, of course. There we go, you should see Civil 3D up there now. Go by Pipe Networks into my parts list, the ANZ parts list. I can go and edit it. Go to my concrete RCRRJ pipes. Just let the screens catch up. Yep, you should see that now. Expand that out, and any one of these, if I wanted to say the 300, I can right click on that and go edit. You look through the at the list here, and we've got inner pipe diameter 3.05. So obviously that's a 300 nominal bore pipe, but the actual inner pipe diameter is 305 millimeters. Obviously they've all been sized so that they're as close as possible to the actual size of the pipe. Some of them actually vary quite a bit, so that when you run your analysis, that you'll get your answers as accurate as possible, well, at least for the internal pipe diameter. All right, so that's where you find it in Civil 3D if you're looking for that. So you need to match that size. For us, we're talking about the 225 pipe. Edit that, and you can see it's 22.2 centimeters, as we've already found out from StormNet. Let me just cancel out of there. Escape out of that and go back to StormNet. Okay, so 22.2 is what we want, and I'm going to just change the description up there to 225 so it matches as well. Okay, if I click on one of the other, or somewhere else on the screen here, you can see that it's recalculated the peak flow, it's recalculated the design flow capacity, so we should be a little bit closer there. 225 is probably the smallest pipe you can get in that in RCRRJ, so we'll have to run with that one. Then close that, you rerun the analysis, so just close the profile. Analysis, perform analysis, rerun it with the smaller pipe size. Go and make out have a look at our output profile plot again, going from there to there, show the plot. And let's just redo that animation, play that one, run through. You can see our lower pipes being used much more efficiently now. It's not oversized so grossly. I'm pretty happy with that. And our hydraulic grade line isn't going above the surface level anywhere. It's not backing up. It will actually flag that with various flags if that is the case. If one of the pipes is surcharged, it'll show you that. Okay, so let's stop that there. Close the animation, and we can double click on that pipe, and it's our flow capacity, and our peak is fine. So we're good with that. All right, let's close that. This this profile plot, we've got a whole bunch of options what we want to show in that profile plot. Just let your screens catch up. Different colors you want things marked, how much stuff, bunch of stuff that you can customize how this actually looks. The reason you would want to do that is that you can, let's go OK on that one. We can right click in here and we can export this this profile. We can export the summary table down the bottom there to Excel or Word. We can print it out directly from here if we want to, if we want a print of what's shown on screen. Or we can, and this is interesting, make a CAD export. So it'll export it to a DWG file. If you have a look at the CAD options here, we can set up what it puts on what layer and what color it is, etc. before it makes that export to AutoCAD. To a DWG file. So that is one option that you get. There's quite a bit of extra information in here that you do not get in Civil 3D, such as the where are we? Maximum flows, maximum velocities, etc. You may want to take it through to AutoCAD that way, but I'll show you what we can get in Civil 3D in just a moment. Okay, so that's all customizable as well. There's a whole bunch of reports you can get out from your analysis as well. Haven't got time to go and have a look at all of those. Statistical report down here, time series by element, time series by variable, Excel table reports, generate custom reports, whole bunch of stuff. And they're all customizable as to how much information you want in those as well. Okay, so there's basically what I'm trying to say is the reports are customizable. What we need to do now though is go and export this information back into Civil 3D so we can use it back there. So we obviously changed these pipe sizes. We want those updates to the network to come through. The way to do that, we've got two options. We go export file, or from file drop down, export. We can export back to a land XML file, but if we actually use this one for hydroflow storm sewers file, it gives us two extra bits of information get taken back to Civil 3D. It takes back the hydraulic grade line and the energy grade line, which Civil 3D can display in your profiles. So just for sake, it also, if you do it via this storm sewers file, which is a STM file, it also allows you to update the existing network, which is quite useful, rather than if you were to take it through as a land XML, you'd have to delete your existing network and then bring this one in its place. So let's go and do that. So let's go and make a STM file and put it on my desktop, and we'll call it SSA STM. There exists. Yes, I do want to overwrite it, and it gives us a little report, but we don't want to save that report, so that's fine. And we can change back to Civil 3D again. Okay, what we do want to do though, there is a little hack that I've figured out how to do. Well, it didn't take much figuring out, but to make this work a little better, if I go to my desktop and open up that STM file that we've just made, I'm going to right click on that and go open with, and just open with Notepad. Let your screens catch up there. In the first part of this STM file, it actually is renaming the network. Well, just the screens are almost caught up. The STM file exported from SSA wants to rename the network. If you don't rename it, well, you'll see the option that comes up. You get an option to update your network if it has the same name as what's currently in your drawing. So I'm just going to come in here down about to what, 15th line or something like that. There's network name. So I'm just going to delete that out of there. And what's in brackets is the bit you want to keep, which is the original, name of the network, which in this case is Storm. So I'm just going to make that little hack for me. I'm going to talk to Autodesk about this and see if they can get that fixed up so you don't have to do this. But let me close this. Yes, I'm going to save that. Go back to Civil 3D. Okay, and now we can import that directly into Civil 3D, and we should be able to just overwrite our existing network. Just let your screens catch up there for a second. There you go. All right, so if we go to the Insert tab of the ribbon, on the left here we have a Storm Sewers option. Just click on that. It asks you to look for the STM file. It's on my desktop. It should be, here it is, SSA STM. Open that one. When I open that, it realizes that it has the network is the same network as the one in my drawing, which is why I did that little hack. If you were using HydroFlow, which is where the STM file comes from, you wouldn't have to do this hack, but there we go. Hopefully we'll get that fixed up. We want to update the existing pipe network. If you didn't have the name matching, you wouldn't get this option, and it would just put another network into your drawing over the top of the first one, which creates a bit of a mess. So we go update existing pipe network. So remember that hack. Okay, and if we go and have a look at our bottom pipe here, select that, go Control 1. Oh, in fact, we didn't want, sorry, that's the AutoCAD properties I'm just bringing up there. I don't really want that. What I actually want is right-click and go to the pipe properties. And that was a 375 pipe, and now if we scroll down to the bottom here, it's a 222 diameter pipe, which it's matched the part as we hoped it would, or as I set it to. So it's actually gone through and made it a 225 nominal bore pipe, which is what we wanted. Okay, so it has made that change when we brought in the STM file. Okay, the other thing we need to do is go back to our profile here. Select our profile. You can see that the pipe network has actually disappeared from our profile. Pardon me. All we need to do is put it back in. So if we select the profile view there, up in the ribbon we get Draw Parts in Profile View as an option. So click on that and it asks to select the network. I just need to go back to my plan view, select the part in the network, go Enter, and it just drops the entire network back into that profile. But what it does do is brings through the, if you have a look on the screen there, it's bringing through the those two lines, the hydraulic grade line and the energy grade line. Energy grade line is the green one, hydraulic grade line is the yellow one, and it's also getting those reported. If we go and have a look down here in the bands, our hydraulic grade line is being reported in the pipe style that is the ANZ pipe band style. Okay, so that's the extra information you can bring through if you're using the STM or storm sewer, sorry, the hydroflow output format. It also gives you the added advantage of being able to update a network as well, which is a little bit, it makes it easier to use when you're working with these profiles that are already been made. Okay, all right. So very quickly, that's the round trip from Civil 3D out to SSA, do an analysis, round trip back into Civil 3D. We've got what I probably want to look at is go and have a look at some of the, just very quickly, the other things you can do with SSA. So if I just go and open another SSA file, pre-made one from some of the tutorial documents for it. Let's go open. And where did I put that? Desktop, Solutions Day, SSA. Let's have a look at this dam project that's been created already. This is one done on the, as I say, in the tutorial files from Autodesk. Just let your screens catch up there. Okay, they've gone through and made a whole subdivision here of this area. What I'm interested in is down in the on the right hand side here in the middle. There's a large detention pond that they've created. There you go, you should all be seeing that now. So here's the detention pond over there here on the right. They have gone through and they've got a bunch of junction structures and pipes in between those. Some of those are open channel pipes, or just specified as open channel, so we get the correct flow characteristics in there. I'm going to zoom in on the outlet structure because that's what I wanted to look at here. What they've done is they've made some dummy pipes in here to work as the outlet structures for this particular dam. So to represent the dam, there's an element in here which is storage node pond. So any of these junction structures we can right click and make them convert to an outfall, or which is a outlet structure, or an inlet, which is a sump structure, or a storage node. In this case I've changed it to a storage node because that is going to, they've used it to represent, pardon me, the actual storage in that pond. So if we double click on that, you can see what they've done is there's a storage type here. It's a storage curve or functional is the option. They've used storage curve, and if we double click on that, go and have a look what they've done with the storage curves. They've made a depth versus area storage curve, so they've just got the areas of the contours out of Civil 3D. Simply you can export the contours as polylines and get the area of the enclosed polyline, of course, directly from the AutoCAD properties, and just specified this is depth in feet, so for 1, 2, and 3 feet deep. There's the various areas, so these storage curves have been worked out off that. So that's what they're using to model that pond. So let's close that for the moment, and we'll go and have a look at what they've done. So that's the actual storage node to represent that pond. That's the one that's flashing in the middle of the screen there. Should be able to see that in a moment. Okay. And what they've done for the outlet structures, they've got a 2-year orifice, so they've got a pipe at the lower level in the structure. They've got a 10-year orifice to deal with the 10-year flood, and then for the 100-year flood, they've got a weir at a higher elevation. So if we can double click on one of those orifices, it's got a rating curve. There's various types of outlet structures for side, bottom, etc., circular or rectangular. It just changes that curve slightly. Well, let's go and do it. So it's a bottom outlet looks like that. If it was rectangular, it probably won't, well, it does change. Or a side, both side circular is what he's dealing with there, and that's the 2-year orifice, and obviously the 10-year orifice is here. It's a larger size, so it discharges at a different rate. So basically what they're doing there is going and matching the discharge of this developed area to the discharge that existed before this area was developed, so we don't overload the downstream creeks and other waterways, etc. And then for the 100-year weir, I jumped in here, and it's obviously not a pipe anymore, it's a weir, and you've got V-notch weirs and rectangular, side flow, transverse, trapezoidal, all different sorts of weirs, just basically puts in a different rating curve, and obviously you've got the different variables of crown length, total height, etc., and the crest elevation is the one that's probably makes the most difference. And that's all to balance the outflow at the bottom of, or the outflow of the downstream pipe. Alright, so that's some of the more complicated things. Obviously you can get very complicated. Over in the tool space here you can see this pollutants can be taken account of. We've got things like pump curves for pump stations that may be in the system. We've got all sorts of different sorts of conveyance links and things that you can put in there. We've got outfalls can have tidal curves, etc. associated with them, so you get different heads at different times. A whole bunch of stuff you can do. Again, you guys will know better than me how that stuff is supposed to be used or how you want to use it. From people that I've spoken to, they've said that this package looks kind of similar to what Drains does. People know Drains in Australia, I know. There are people in Australia and New Zealand who have already been using StormNet as it was. So it's a much more accepted piece of software here than what HydroFlow was, which is very Americanized. Just one other last one to show you here. Let me go and open that. The gutter. Again, those junction nodes, you can change them so that they're actually actual inlet structures on a road. So if I was to come into, zoom into this area here, any of these junction structures I'll just let your screen catch up, zoom in. I can just click on one of these, right click on one of these junction structures. This screen's still catching up by the look of it. There we go. Right click on one of those junction structures and go convert to inlet. And it puts an inlet structure there. You can see these ones have already been done. That's an inlet like a sump. Now I can convert it back if I've got that wrong, obviously. Put it back to a junction, it becomes a junction again. If I double click on this inlet, you can see it gives the characteristics of that inlet, and it works out as when you do the analysis how much flow is going to be intercepted and how much goes past. The thing I wanted to show you in here was that this one here, for the flow that goes past the structure, it's got a roadway / gutter bypass link, and there's one called gutter here that it's using. So it's going to go down a link if there's too much flow for it to be intercepted by that particular structure. Obviously you've got the grate length, grate width, and the curb opening widths, etc., and different sorts of inlet types that you can specify, circular ones, etc. Combination inlet is what we're more normal for New Zealand anyway. If we go to back to the map here, you can see they've specified a bypass conveyance called gutter, or it's just simply another link like a pipe, except in this case if I double click on that, it's actually, instead of being a circular pipe, it's actually specified as an open channel with a triangular cross section. So that's how they're modelling the bypasses to those. So if there's too much water comes in to the top sump, which is all coming from this roadway 1 area, goes into there. If it can't intercept it all and take it down to those first ponds, it'll go past that to this next one and then go down into the next lot of ponds or the next area of open channel flow down here. So that's how you'd set that up. And obviously you can get very, very complicated with these things. All right, well, more or less that takes us to the end of where I wanted to get to in this session. So hopefully that gives you something to start with. Oh, I think my audio has just been lost, so let me just wait for that to come back. Hopefully you guys can hear me again now. My web link just went down there for a moment, but yeah, hopefully that's given you enough to make a start with SSA. For many people, that will be as much as they'll want to do. Just take a network, analyze it quickly, that's it. For a lot of people, you're going to want to do a lot more with it. It has the potential to do a lot more. And obviously, you'll be able to rip into that. All right. So what I'd like to do is just say thank you for being in on the session today. Hopefully you've learned something, and we'll look forward to seeing you again on another webinar as they come up. Thank you and have a nice day.